further understand the probability theory, let us understand what we mean by random variable. Let S be the sample space of an experiment. Let A1, A2, An be the collection of events which form a partition of S. That is, they are mutually exclusive and exhaustive. If to these events A1, A2, An we assign a number, say x1, x2, xn, then such a number is called random variable. In other words, it is real valued function whose domain is S. So we have the following table for better understanding. First row represents the set of events A1, A2, A3, An, which are exhaustive as well as mutually exclusive. Then corresponding to A1, A2, A3, we give them a number, just as roll numbers are given to the students in a class. Similarly here, random variable x is to associate a number to each of these events. That is, A1 is given the number x1, A2 is given to x2, A3 is given x3, and so on. An is given the number xn. Now the third row provides the probabilities of the events that are listed in the first row. That is, probability of these events. P1 stands for the probability of the event A1. P2 stands the probability of the event A2. P3 stands the probability of the event A3. And Pn is the probability of An. Mind it, A1, A2, A3, An are mutually exclusive and exhaustive. Consequently, the sum of the probabilities will be 1. That is, P1 plus P2 plus P3 up to Pn will be equal to 1. That we discuss later as well. We have the following from the above discussion. That is, A1 union A2 union A3 union An is equal to S, and Ai intersection Aj, I not equal to J, is equal to phi. That is, they are mutually exclusive. The random variable is a function from S to X, the set of random variables. S is the sample space. That is, every member Ai goes to a real number xi. No two members of Ai and Aj go to the same real number. Number 2, we already have a function from S to R. That is, every event Ai is associated to a real number which is its probability. Number 3, now we have a function P from X to R. That is, P Pxi is equal to probability that x is equal to xi, which is equal to pi. This function Pxi gives the probability of that event whose random variable is xi. It is called probability function or probability distribution. Thus, P x to r, where x is the random variable which takes the values x1, x2, x3, dash dash dash, and their corresponding probabilities are P1, P2, P3, dash 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 Pn. So P x to r, where xi goes to Pxi, for all xi belong to x, is called a probability function. Now we have following notes here. A random variable which takes a finite or countably finite number of values is called a discrete random variable.